Albert Einstein completed his theory of general relativity only after another decade of difficult work. So, the general theory of relativity, published in 1915 in a form of extended special theory of relativity. However, if special theory of relativity focuses on the inertial frames of reference, the general theory of relativity revolves around non-inertial frames of reference. This theory tackles the concepts of the space-time continuum and its curvature, as well as how various forms matter are distributed throughout space-time. The theory also holds a different view of gravity as opposed to the classical perspective. Basically, its main concept is that instead of being an invisible force that attracts objects to one another, gravity is a curving or warping of space. The more massive an object, the more it warps the space around it. For example, the sun is massive enough to warp space across our solar system, a bit like the way a heavy ball resisting on a rubber sheet warps the sheet. As a result, Earth and the other planets move in curved paths around it. This warping also affects measurement of time. We tend to think of time as ticking away at a steady rate. But just as gravity can stretch or warp space, it can also dilate time. General theory of relativity holds that what we perceive as the force of gravity arises from the curvature of space and time. In fact, it is the best description of how gravity works. General relativity is more complicated. Its field equations describe the relationship between mass and the curvature of space and dilation of time. Shown here in a picture, Einstein's general theory of relativity suggests that the sun's gravity bends the path of light from distant stars, and it's a testable prediction, but only during a total solar eclipse. The eclipse of 1919 fit the bill nicely. Einstein's theory said it should be that light bends in the presence of mass. In this case, the mass of a star or sun. Rather than traveling a straight path, the light of distant stars was forced to travel a curved path on a curved space near the sun. We must take note that the theory about space-time continuum had already been present prior to the conception of the general theory of relativity. However, the most important part of the theory that helps substantiate the concept of space-time continuum, was the idea that gravity is simply a bending of space-time.